Hello everyone, let's wait a little bit until other joins and then we'll start. Okay, guess we can start. So hello everyone. Let's start the session. So yeah, the plan for today is that we finished the overview for the assignments of about the strings. So we'll have we'll quickly go through the possible solutions for the fifth assignment for the strings, and then we'll quickly go through the second and third assignments, and then we'll go to the object-oriented programming topic. So that's the main plan for today. For the next time, not the next time, but the next week, I will explain in details, more details tomorrow, and actually then I will share the file where you can actually write the topics you may want to discuss in more details, maybe review some points from them, and so then we can discuss these points next week. But I'll let you know more about it tomorrow, so then I also share the file with you. Okay, for now, I guess we are ready to start, so I will open the Visual Studio Code, and here we can implement the assignment number 5. Okay, so let me then so idea is that we check if the word is humdrum or not. As I told you last time, there are two most obvious solutions for this. The first one is that we simply reverse the string, then we check if the strings are the same. Like we have the original string, then we create the reverse string, and then we check if the strings are the same. Also, the option B, that's the first option we'll check today, is that the characters. So again, since the strings are the sequences of the characters, that means that the characters from the end should follow the characters from the beginning. Yeah, and in this case, if the characters are the same from the beginning and from the end, then it means that this is bound. Also, there are some steps, some small things to add here. So we'll maybe start with the creation of the class, and then we'll so that should be assignment, assignments, yes, of course. And then we can start calling here. number class, that would be assignment number 5. So the name of the class and the static method. Again, this method is point that we have for the static void name, of course. Then it then we can write. So first of all, we need to read the input. That's obviously. So then we ask user for the input. Console, we have write line, so we ask user to please enter the word to check. Yeah, so then we ask user to input, so we provide the input, so I'll create a variable where we'll store this text. So we have new line as always, and then I can do the operations, I can do the checks on this string. So first of all, one thing, as you remember we talked about last time, there are the spaces, there may be the spaces in the string, and there may be some commas or dots or other non-alphanumerical characters, and we need to escape them. Also, one more thing is that you may see, for example, if we go to the strings provided here as the examples, then you can see that if we just directly check the characters like M lowercase and M uppercase, they're not the same, right? So in this case how we usually proceed in such cases if we need to perform non-case sensitive check. And the usual approach would be that you translate both the word you compare and the word you compare with into the same case, like if it's lowercase or uppercase. Yeah. So you can choose what you want to do. You can choose to translate to lowercase or translate to uppercase. So then you translate to uppercase, and then it will be like this, and then the check is not case sensitive anymore. And so this is what we do here. So that's why here I can directly perform to, let's say, to uppercase. Yeah. In this case, it doesn't matter if it's lowercase or uppercase, since we check the boundary. Yeah. Means that it should be the same for both sides, from right and left. So, and then I need to check if the string is polygon. Again, we have, the easiest option would be that we simply compare the characters from left and to the characters from right. And one more thing, again, I will use regex to then replace all non-alphanumerical characters. And so in this case, I can go to the string, say text equals, and in this case new string will be created. Yeah. So it will not be the same string, it will be a new string here. And here we can ask user, not ask user, but here we can actually provide the, not from text, in this case we'll use regex, of course. Regex, and we'll replace from regex. That will be text, yeah. The string we want to, we are checking. Then we go to then we search for the pattern we want to replace. In this case, I want to replace all non-alphanumerical, means non-alphabetical and non-numerical values. So in this case, I can do as I shown last time. So I provide the pattern for the characters first. Yeah, for all lowercase and all uppercase characters. Actually, in this case, since we don't have we won't have lowercase characters because we already translated to uppercase. So in this case, I can in theory skip this AZ because AZ lowercase, because we already translated to case. And then we have 0, which means that we check all the digits. And then we provide with what we want to replace. So this will be empty space. Or just not empty space, but just empty string. Yeah, at this point we'll have the string where all the characters are in uppercase, and there are no spaces, no commas, no dots, and so on. Yeah. So here, just for the user, I can write the text. I mean the text what is checked. Yeah. So text to check. So just at this point, how our formatted text will look like. This is definitely the text we're checking. And okay. So now I can provide the check. So again, approach we'll use. We'll go from we'll check if the characters from left are the same as the characters from right. So how can we do it? Of course, using the loop, right? So from this point, yeah. So the question to you: which loop may be the best one to check the characters from left side if they are the same as the characters that will go from right side? Yeah, like we check the last one, the first one with the last one, and we check the second one with the last one minus one, and so on. So, what do you think? What's the best option? Substrate, yeah, I mean reverse, yeah, but I mean in this case we'll just simply check the characters. We'll not construct a new string. Yeah, because if you want to, as I said, yeah, one of the options will be that we use reverse, but in this case we'll create a new string which we actually don't really need. Because it will still take all the actually it will take even more operations to do. But in this case, for each, I guess the easiest way for each, this I guess won't be the best one, but of course that would be simple iteration int I equals 0, I is less than, and in this case, yeah. So we don't need to. So that's the loop. Yeah, we go from left side to right side. But in this case, what will actually happen? We will reach the half of the. Let's say we reach the half of the string, the half of the text, and at this point it means that we checked all the sequences in the first half with the sequences of the second half. Yeah, so in this case, the right half of the string will already be compared with the half, with the right half of the string. So in this case, we don't need to go through all the characters, yeah, because we just simply need to reach only the half. In this case, that would be that we say text once divided by 2. And in this case, yeah, you may, from the mathematical point of view, you may actually theory comply if there is if the number is odd or even, but in this case it doesn't matter, because for palindromes we have nothing to check with the middle character. Because let's say that we have something like this mount, that we have just any character, let's say t mount, and in this case we'll have 7 characters, so it means that once divided by 2 will be 3, and in fact the 4th character, we are not interested in the 4th character, right? Because we have nothing to compare. Yeah, what we'll basically do, we'll compare again the first one with the last one, then the second one with the last one minus 1, then the third one with the length minus 2. Yeah, and like if we have larger string, and so on. Yeah, so in this case we only need to reach half, and again, if we have the middle character, we are not interested in it. And so middle character will be skipped. there can be split since we don't compare it with anything. Yeah, so that's the point. And yeah, so now we just simply check the first character, the character I, with the character with the last one minus I. Yeah, so in this case we have, and yeah, so in this case what will actually, yeah, basically, yeah, here we will of course add the check. So if text I equals text, so and here we have the length. Yeah, and we definitely need -1. Yeah, that's correct. Yeah, I mean that's absolutely correct. In this case, we are sure that this is not palindrome. So definitely minus I. Yeah. -1 minus I. Yeah. That will 100% is correct. And yeah, so in this case, we just only need to find out the way how we can actually will present it to our program. I mean. Yeah, so in your case we return false, in this case the program will return false, otherwise we need to go through all the loop and then we will return true. Yeah, so in this case that will be correct. Yeah, so then, and if we gone through the loop and everything is fine, then we can return true. In this case, yeah, since we have the static method, we have no returning tag. In this case, we cannot really return true, but what we can do the following way. We can assume that the default value is true. So by default, we assume that this is palindrome. We assume that this is true. Yeah, and in this case, I say that that is false. Yeah, so in this case I know that this is not palindrome, and in this case I have actually no reason to go through the other entry, since I already know if at least one character is not not equals, if at least one matches, at least there is one pair which does not match. Then of course the palindrome is false, and then no need to check it further. So, since we do know that it is not the palindrome, we can keep checking further. Yeah, and at the end we just simply need to print the result. So how can we print the result? Of course we can create if else, but we have shorter way. I presented you once, and the shorter way, I mean, you can write if else, that would be correct, that would be the same as what I will write now. So in this case, I say if palindrome is true, is it true or false? Then if it's true, it will print this is palindrome. Else it will print string. Else it will print this is not okay. So let's check now. Standard 5.cs. Need to write the name of the file correctly. Yeah, sorry. Yeah, of course, needs to change the false, so that will be strings as length. And now I can compile the file. So it is done here, then I can execute, and let's go through the examples we have here. So first one we have mom, right? Yeah, so then we can see that mom is palindrome. Let's move on. Let's check, was it a car or a cat? So not that long. Yeah, just okay, so that was fun. So that is correct. Then we can also check the next one, and maybe just in case you sometimes have copy-paste issues, you may simply copy a plain text and not button, then note that you can copy it and then paste it. And 7, 5, okay. So this is palindrome. Let's check the last one. So now all the palindromes are in place. Now let's check something which is not the palindrome. So let's say we check. So this is the text. Check something like this, and yeah, and you can see that this is not the palindrome. Yeah. So yeah, that is the solution. Of course, one more thing is that you can create the reverse string, then simply check the reverse string, and then compare the strings. But in this case, that's faster. It is faster to check the characters. Because again, if we need to check the characters, then you can see that it takes length divided by 2 steps to check. If we need to create a reverse string, then it takes length steps to actually copy the string. And in theory, the time is linear, so in both cases, the time complexity is the same, but yeah, so here you can see that this is a little bit faster, and we don't spend any money, of course, to create a string. So in this case, that is quite an efficient solution. Okay, do you have any questions about this one? Okay, then if not, we can quickly go through the second and third assignment, and then we will move to the presentation about object-oriented programming. So let me create the file. Copy paste something from the previous. Assignments. Okay, so let's oh no, so we have the second one, sorry, the second one, maybe let's start with the third one, then we'll move to the second one. Hope that this is not a huge issue for us now. And yeah, so here we have the third one, create a write program when multiple actions with string will be performed. So first we'll create a string. And find options, not sort of working C, but you can see the world. Okay. So in this case, it's simply hard called the string. Copy paste that. Excuse me. copy paste the text. Of course, the notation marks should be correct. They shouldn't match. Okay, so then next one. Take a look on the potential string. Okay, print out how many words are in this. Actually, we already did it about words in the sentence, didn't we? Yeah, I remember. I remember we did it actually before. So, but okay, so then we can repeat it. So as you remember, what we can do, we can simply split the string and then check the length. Right? So that is how we can. How we can check how many words there are. So, but yeah, so we can do it. So in this case, I can write the one. Then I can say there are. Then text split add action split a space. Then this will return the array. Actually, we can store this array and split it every time. So here we'll have words, and then we'll split it add space. So and then we can say that there are, not space, but words. So in this case we'll have the array of strings, and we can find out how many words there are using the split and count. So yeah, actually we can use count. Yeah, so in this case, that is correct. Again, there are different options you can find actually. So for the string, there are no such methods which can count, but yeah, if you can split and then simply count using one. So there are two words in the say sentence. So this one is done. So next one, take a look. Yeah, that is done. Print out. Yeah, that is done. Find out how many dead words are in the sentence. Yeah, okay, so we can do it. And then I can count it this way, so we count dead. And we always start at 0, of course. The counting that we start at 0, and then we simply do for each. Okay, yeah, for each, then yeah. So for in C# you can simply use var instead of type. So that is called inline decoration. It means that it will just simply recognize the type automatically. Yeah, because we know that for the array of strings, the type will be string, right? If we do for each loop, yeah, so we cannot have any other element but string. So if we use var, then the program is quite smart to understand that this will be string and nothing more. So that would be word and say words. Yeah, that in this case that word is the same as if we say string, but just be more. So now difference in this case if we use var or string as the type. Because again the var is just smarter, but for the program perspective, the program is smart enough to understand that the type will be string. That's why we can simply use VR in this case. Okay, then secondly, we need to remove all the non-alphanumeric characters in the word, yeah? Because, so, hold on, we have this fifth one. So here we remove all non-alphanumeric characters. So then we can do it actually. So then I say, let's say word. And this will remove, because again, in this case we don't really need to check the commas, the dots, colons, semicolons, and so on. In this case I simply replace them. And also I will do it the same way as before. I will translate them to saying all, because in this case it doesn't matter. And then what we simply say, if word equals that, or I can also do the same way. Again, in C# the operator is overwritten, so it will work the same as the equals method. So in this case it doesn't matter. Let's write the comment the same as word equals. So and if it equals 10, then I can simply increment the counter. Yeah. So this is done. And then I can write the output. There are counts the sentence. Okay, so this is done. We have asked the next one. Find out how many words consists of the letter S. Okay, then we can do basically the same. I can simply use the same loop. I can simply use the same loop. Yes, we'll have count S. And then I can check the next one. If word contains, so we have contains. And we can check if it contains the string or if it contains the character. In this case, we'll check the character. And we'll implement counter S. So this one is done. Then we have the next one. Find out the words that are repeated in the sentence multiple times. Okay, so that would be more tricky. In this case, again, we need to check if the element of the array is repeated. So that will be more interesting. In this case, what I can do, yeah, actually the easiest way to do it would be to use the collections. But since we didn't talk about the collections, so then we need to proceed manually. For the collections, that would be done in the way. So just a short introduction to the collections and to the tables from data structures point of view. So for the tables, we have the keys and we have the values. Yeah. So yeah, and the key may only be unique, and the values may be not unique. So in such case, let's just imagine that you have the basket. So you have different baskets, just any baskets, and for each basket you have unique name. And using this key you can actually access the corresponding basket. And so in case we use the collections for such purpose, then for each collection we have the entry, for each collection we have the entries. For each collection we have the entries, and then for each entry we have the key. So in this case, that will be that we have the keys as the words, and then for each word we can simply read by key and check if the word is or not there. But okay, in this case that will be maybe more further topic for us. In this case we will need to so in this case we actually have the only thing we can do is simply do the for each. Yeah. And yeah, so in this case we don't need to count them, we simply need to check if they are repeated. So in this case I can do the following thing. So first of all, I create a new array. In theory I can use the same, but again, since we need to escape the all non-alphanumerical characters, then we need to use these words. Yeah, I mean without the commas, without the spaces, and so on. So in this case, what will I do? I will create a new array. The string, and that would be words. Just words, say, alphanumeric words, something like this. And then we'll create a new array. And then the size of this array will be the same as the size of one, but then content will be a little bit different. So in this case, inside this loop, I will add this element to the array. So that would be alphanumerical words. Then in this case I have for each. That won't be good. Okay, so in this case, yeah, in this case I need to have the iterator. Okay, well then maybe let's not rewrite the loop, but what we will do, we will create the simple iterator, and then start with 0 as always, and then from here I will do the following way. Then I will assign this word here. Yeah, so in this case we just simply create a copy of the array, but inside this array we will not have the strings, the words with the commas, with the underscores and so on. Yeah, only alphanumerical characters. So then this one is done, and yeah, so then next one I can create a separate loop. So the separate loop is yeah, the interesting thing is that no, actually I don't need to store them anywhere. Oh, no, hold on. No, I don't need to store them anywhere. Okay, so in this case I'll create the loop, and then the idea would be that this loop will have the iterator, yeah, to have I, then I should be less than first the size of the array. So we'll go through, in this case we need to go through the array twice. I mean, we'll need to have the inner loop. So in this case I will then go through all the elements here, and then inside this one I will need to go through all the elements again. Yeah. So yeah, we'll see there will be one mistake, but we'll try to solve a little bit later. So in this case I will create the same loop, and then I will adjust it using J. Okay, and so here I need to check. Well, no, hold on, we actually don't need to start yeah, in this case we can simply start at I, because we don't need to check what was behind. So that will be done starting with the next element, and then we're finishing at the end. And since we, in this case, we don't need the last character to be checked, because again, the last character has nothing to be checked with. So yeah, and then first we need to, then we can simply check if word, so that would be that alphanumerical words I equals, and just not confusing it. Let's use equals, so you can simply use, but again, just to make it different. Again, no difference if we use equals or if we use the symbols, that would be the same. So here we compare J with J element, and then if they are the same element, that the word is repeated. Easy, but one is repeated. And in this case we can actually also break the current loop, because we already know that this one is repeated and we don't need to check it twice. So this is done, and okay, maybe I will then switch this loop before. I'll switch this statement and put this here. So what else do we have? Of course, we need to also print out the R and S. So S words and this words which consist of S. I guess that would be fine if we name it this way. Okay. Then done. Then what do we have? Next one is okay, since for example, yeah. Okay, change the word you to you, print a new sentence. Okay, that would be easy. Because so, sorry, yes, inside the method. Just be careful when you write one, and then I can simply write the adjusted sentence here. So that will be the text. So that would be the text here, and so that would be the text here, and then I can simply replace the characters. So that would be no, I will not replace the character. I will replace the old value with the new value. So in this case, what I need to replace is that I need to replace the what I need to replace the u with u. So that would be u. I replace it with the new value u. Okay, so that is done, and then we can move and check it. So that would be MCS assignment 3.cs. Okay, so here we have the issue. I cannot assign to what because it is for each. Okay, yeah. So since we use it for each, then we cannot actually change it here. Okay, so in this case, I will say that word is adjusted. The word adjusted, and then I'll use it here. Yeah, so that will be the only difference. and I will use this just for, yeah, so the idea is that for each loop, we cannot simply change the value then. Yeah. We can only use the same value. Yeah. Okay, so this is done, and add. So what else do we have? The name does not exist. That is the line 37. Oh no, it's line 19. Ah, yeah, of course, this one. So it'd be not I, but iterator response. Okay, so that is done, and now we can run the program. Oh, sorry, I forgot to mention which word is repeated. Oh, no, so that's empty space. While is repeated. So we have words, right? Oh no, we have, yeah, so there's moving the sentence. And then we have this point. Okay, so here we have if word adjusted equals. So do we have, okay, we do have one moment. Okay, so that is done. Let's maybe print the adjusted word here. Okay, so let's print the word adjusted. Some yes. Let's run the program. Okay, so it seems that it just basically replaced everything here, which is, I would say, a little bit crazy. That's crazy. So why we have split ads space. Okay, maybe let's also write the word which is not adjusted. So the word which is not adjusted we can also print it here. So just in case you notice the mistake right now. Oh, yeah, sorry. Yeah, thank you, Anastasia. I simply copy paste from the previous page and forgot about overcase. Yeah, thank you very much. Thank you. Yeah, overcase is forgotten here. Yeah, sorry, thank you very much. That was forgotten, and yeah, so now I can say that word so is repeated, word that is repeated, word not is repeated, and word can is repeated, and word see is repeated. Okay, so let's maybe then we don't need this one anymore, and then we don't need this one anymore as well. Okay. So that is done. Let's maybe double check. Yeah, thank you, Anastasia. Thank you very much. Then this is fine. And then let's double check these points. Yeah, 16 ones in a sentence. There are two dead in the sentence, 5 has words in the sentence, and here we can see all the repeated words. Okay, so now it is then actually done. Do you have any questions? Do you have any questions about it? Okay, then if not, then we can... Okay, Sabine, questions, yeah? Okay. Yeah, definitely I can push the codes, push the code changes. So then git add, git comments, and the message that will be times date, which is the first one, and then changes. So just not rewrite the code, you can take it from here. Okay, so that is done, and so then the last thing we can quickly do the... Actually, maybe we don't need the second one, because the approach would be the same. So, okay, then the second one, we can maybe quickly do it. So there's no rush for us. The assignment 2. Let's see else, and here then we have it in here. Okay, so that is done. The assignment 2, and the approach would be quite similar to what we had here. Well, it's actually almost the same. So then first we need to create the static void main. So that will be static void main, and then we can create the error first. So the string. The string, and so here we can create the array. B, so the array, and here we can simply copy paste the values from here. Then I can replace these quotation marks with this one. So I can simply replace all, and I can also replace these quotation marks with the correct ones. Okay, so now it's done, and now I can start working with this array. So first of all, we can check how many errors, how many values starting with C. So I can then do something similar I had in the previous task. So that would be count, let's say count C. So usually we always start with 0, of course. That would be count C. Starting with C, and then I can go through all the elements. I can use var, I can use string, it's up to me. Then I say element in array. Then this would be yeah, so here I simply need to change the first character. So then I say if elements char at, oh no, just simply first character. If it is C, then I simply increment C. Okay, then the next one is how many values are ending with E. So then I can again see if elements be the length of the elements. Length equals E. Then I can count E here and start at 0. Then we simply increment count E. Then we find how many values are on 5. So then again I can do the same here. Count 5. Start at 0. Then we simply say count 5. If elements length equals 5, then we increment count 5. Of course. So then when we have found how many values consist of the character E, then we say if element contains character E, then we can say count E, let's say exist, attention that exist. So that would be count exist. We'll increment this one. And then also if elements contain, so in this case we can simply check if it contains the substring, so then we can use the same method contains. So the substring will be TE. And here I can check counts TE, start at 0. And I'll increment count TE. And the last one is histogram. So the histogram would be that would be more complicated thing, I would say. Yeah, to implement the histogram, that is more interesting thing. We can actually do it. But in this case that will actually we can reuse, to find histogram. To find histogram, what we need to do, we actually need to values rated of calculate histogram values related to length of value. Okay, so in this case we have the length of value. And so check the length of value. We can firstly simply, during the first loop we can check the maximum value. So how to get the maximum value on the element of the array? That will be simple. With max length, so we start at, let's say, -1 just to be more precise, and then we check if length of the current element is greater than max length, then we say that max length equals current element length. So why do we need to do it? We need to, so since we need to create the histogram, we need to find the range. In this case we assume that the range starts at 0, that's obviously, and we will finish with the maximum length. So then I simply assume that we now create the array. So that would be the array of strings. No, it would be the array of integers, since we need to check the length. So, and I'll say that this would be histogram. And then this would be the new integer array with the length which is maximal length. So, and for now I will go through the loop again. Three for each. Then we have the element again. Then we go through the collection we have. And so then what will simply I do, I will increment the current element. So we will have, oh no, I'll increment the current length of the array. So then this will be like this. And yeah, so now we actually have the histogram. So now let's quickly write the output. So just to follow the task here, so we have start with C, then we have ending with E, ending with E, then we have length 5, count 5, ending with 3. Length 5. So then we have consists of character E, consists of the character E. And so then we have consists of the substring TE, substring TE, and yeah, then the histogram. So for the histogram, I will for the histogram again we can also print it in the loop, and here I print this histogram that we created here. So then it will be so size maybe, and histogram will be, then I'll say, I'll write the line, and here I'll say there are, sometimes will be size words with the length. Oh, here we need the iterator of k. Sorry. We'll see why. We'll say, oh, I equals 0, of course. Say I is less than the size of, oh, sorry, not for each, but 4. Yeah, because we need to have I in this case. So then the I will be the size of, less than the size of the histogram. And then we'll increment I. So then the size would be histogram element I is the length, and the length will be actually the current I element. So, and now we can print it. Standard2.cs. Oh, hold on, we need to, because I have the typo here. Okay, not the typo, I have the issue. Oh, no, hold on, I need to change directory. Strings assignment. And so here we need to compile. Okay, now it's compiled, and now can you see here we have a habit exception. Where it is? It is next result of the balance of the array. Okay. Ah, of course, length minus 1. In this case, we have length minus 1. yeah, in this case, yeah, 1 minus 1, and yeah, so then here we need to have the 1 I plus 1, because in this case actually the index of the array will represent the size of the element. So that is the option we can proceed here. And so here I will, not the 73, sorry, 72. Okay, let's check if it is correct or not. Okay, so still we have this exception. Where is it? Here we have the 1 minus 1, so here that can be the only option where it can be. Ah, of course, so here another point is minus 1. Here as well. So, hold on, yeah, that will be minus 1. So, and here I will compile again. So this is called runtime exception, so the compiler cannot check add. So here we have the histogram. Again, I'm not sure. I'm not sure why. Okay, so here it means that we did not fill it. Says that for all elements the size is says that for all elements the size is 0, which is not. So it is the length. The length will be hold on. Histogram. Okay, okay. So that is correct how we print it. But where is the issue? Where is the issue here? So for the length we have, so it means that the histogram is not filled. So what are the ones we have? So let's say we have 1, 2, 3, 4, 5, 6, 7, 8. And of course here we have 0, right? Yeah, okay. So where is the issue? So here we go through all the elements. So here we have the length of the element, minus 1. Minus 1 because we just simply start at 0. Oh no, sorry, here we need to have max length plus 1. So maybe just at this point, because the idea is that the length can also be 0 in theory. So in this case, sorry, plus 1. Oh no, plus that. That is correct. So, okay, then we can see. Okay, we can skip this plus 1. And the 1 can also equal or can also be the same. Oh, hold on. Oh no, that should be correct. Minus 1. Oh, hold on, so where is the issue? Okay, then maybe let's have 10 minutes break, and after the break I will find out the issue. If you can see it already, then please let me know. But now let's have 10 minutes break. It's 7:15. Okay, let's continue. So the problem here is that we have the one which is oh no, hold on. Whoa. So in this case we'll simply okay, maybe last thing what we can check here is the actual length what we have here now after this trend. So let's then check it. So let's compile code and then let's execute the code. And we have execute. So here we should have the values printed, and we see that it is okay, we see that it is always 0. Okay. Then what we can just simply do, we can say that in the following way, have the previous value, that would be, oh yeah, of course here we have postfix increment again. So, and then we have the previous value plus 1. And so in this case we do the prefix increment. That's a typical mistake, I guess, for me at least. So yeah, in this case I guess it should be better. So let's compile the code now. Let's execute the code. Okay, so yeah, and at least what do we have here? We have the histogram, we have 3 words with the length. Let's check what we have with 0 words with the length 0. Then we have 3 words with the length 3. It's correct. 1, 2, 3. That is correct. Then we have 1 word with the length 4. So that is girl. That is correct. I guess we have no more. And okay, yeah, then we assume that everything's fine. And 1 word with the length 13. Okay, so this is how we created the histogram. So basically the approach is that we have this range of values starting at 0 and finishing with the maximal length of the word we have in this array. So in case this word is, so just in this case we go simply through all the possible values, yeah, and then we navigate to this element and we increment it if we match the word with the length which is actually the index of this array. So that is actually how we created them. Okay, so do you have any questions here? This may be a little bit tricky for the histogram, so in case you want to check it out, so you can check the code and let me know if you do not understand something from here. So, any questions about it? Okay, see Anastasia is typing. For the counting, I guess it's pretty much the same as in the third assignment. So counting, we just simply check if the last element is seed, the first element is seed, and the length is 5, then the I agree, histogram is hard to understand. But so the concept is quite simple. So the first one, what we check. First one, what we need to detect is the maximal value of the maximal length. Yeah. So basically, what is histogram? Histogram is the like we have the value, yeah, like any value. In this case, we have only integer values from 0 to something. And the idea is that for each value, we need to find out how many times it is repeated. Yeah, so in this case, we check the length, and length, that's the integer value, right? So that's the integer value, which can be 0 if the word is basically 0. Or it can also be, in this case, we can start at 0, so in this case, there's no difference because the maximum length can be 0, or minimum length can be 0. So, and here we check. Here we basically check for each length, like the length can be 0, the length can be 1, the length can be 2, the length can be 3, and so on, then the length. And when it, so the question to us is, what is the at which point this histogram will finish? And the answer is simple. The answer is it will finish at the maximal, as the element with the maximal length from all the elements we have, right? Because we cannot move further. So the last element will be the element with the maximal length. Yeah, and so what's the solution? When we talk about the collections, we'll see that solution can be a little bit different from what we have here. But for here, the most simple solution will be that we create the array with the length, which has 0, 1, 2, 3, and the last element is actually the maximal length of the maximum length of the strings we have here. Yeah, so in this case, this is what I actually do. I do +1 because, again, we know that the array starts at 0, so it means that the length will be, the actual length +1, yeah, because +1 is here, because the arrays start at 0. But we have maximal length, which is something. In this case, that's 13. And so we need to finish at 13 elements. Yeah. So that's the thing. Yeah. Now we have, and what we have now? Now we actually have the arrays with the index 0, 1, 2, 3, 4, and so on. And the last index is 13. Yeah, so the maximum length what we have here. And the idea is simple. Then we can use the index as the key, as the key for our value, and then we can simply increment this value. Yeah? So what we do here, actually, we go through all the elements of our initial array, and then we simply check the length, and the length is actually the index of our histogram array. Yeah, so the length of the word from the previous array is actually the index of the histogram array, this one. Yeah, and basically the idea is that each index is actually the length of the word. Yeah, in this case, of course, some words will be skipped here. Yeah, there will be 0 words with the length 11, and some. Also 0 words with the length 12, but the idea here is that the indexes are used as the keys. So yeah, that is hard, so you can think about it, but it's quite, I would say, it's pretty much interesting task from the algorithmic point of view. Okay, do you have any questions? This, yeah, the histogram concept is a little bit tricky, but when we talk about the structures, data structures, then there will be collections, and for collections, for the mapping collection, this will look a little bit easier than you see for the arrays, because the arrays is, one say, quite primitive structure, but comparing to the other collections, the arrays are quite simple. So we have not so many range of operations to we have no many operations to do with the arrays. That's why we are limited in this field, and that's why we need to write some algorithms. But I would say the task is quite interesting. It's not simple, but it is pretty much interesting. Okay, so do you have any questions then? Okay, then if not, yeah, basically again, as I said at the beginning of this session, I will then share the file where you can write the topics, what we can repeat, and then we can do the repeating on some topics on Monday. And so I will share the file with you, most likely I'll do it then today, and you can simply write the topics you may want to discuss. So just in case you missed, something, don't worry, we can repeat it later then. Alright, and finally we go to the topic I was actually mentioning a lot before. That is object-oriented programming. And yeah, so that is quite it's a quite important topic in lots of languages, and basically that's the topic which is the largest one, and that's the most important topic, I would say. What you may learn, also saying from my experience, because working with the objects, using the object-oriented programming is quite important thing you may face in say in lots of different environments, and if you switch to other languages, then it is used everywhere. But okay, so just then let's start. Let's start basically from the beginning. So basically, what we have in real life. In real life, we actually have the objects in real life. So, for example, we want to build a web store, and computers are sold. So how do you do it? Each computer is an individual item, so that's something really specific, individual, which has its registration code and all this stuff. It has the components. Yeah, the components like RAM and the hard drive, SSD, disk, the graphical card, and also the screen. Yeah, so lots of different things, and the camera. And yeah, so basically we have the object, we have the constructed object. And yeah, so then let's imagine basically what is the object, and I mean from the physical point of view. So each detail is say not unique, but it is separate. Yeah, so like you may take the key from the keyboard, then you will still have this key. Like it will not change to something else. Then the key point is that you have the computer. Yeah, you have the computer, you have the structure of the computer, you have all the elements combined. But what's the difference? What's the point here is, let's imagine that you have two same computers. Like you have, in this case we have one MacBook Air, but let's imagine that you also have another such computer. Yeah, like you have two MacBook Airs. So what you have in common? In common you have the same class of the computers. Both of them are MacBook Air with the corresponding model. Like let's say it's 13-inch, the same year, basically the same model. Yeah, you have two or more computers with the same model. Yeah, so all the things are the same, but they are two different computers. So in this case, what you have two objects, two different objects. Yeah, they have different physical, from programming point of view, they have two different instances. They have their own components. Yeah, the components are also the objects, but they are separate, but they both belong to the same class. Yeah, and this is what we basically call the object-oriented programming. In object-oriented programming, we have the classes and we have the objects, which actually belong to these classes. So in this case, we talk about the computer. So the class would be MacBook Air, like 13-inch, the model XXX something. Yeah. So that would be the exact class. Yeah. And basically from this class, actually the computer is created based on this class. Yeah. So more things what we can see here. There's also such thing abstraction. We'll talk about it a little bit later, but in general, just to understand what the abstraction is, so this is the same as we talked about some functions, some methods. We don't care about some things, how they work. Like for the computer, we don't really know. I mean, in a normal case, of course, in some case, you may know how some technical things work. So in theory, that's the same like if you know how the electricity works. So like in theory, if you just simply take the computer and use it, you don't know how different operations are defined there in computer. How do they actually work from the technical point of view? How they interfere with each other. You simply have the front side of the computer, you take it and you use it. Yeah, so some things are not directly available to you. You do not really touch it, you just simply use them, and this is what is actually called the abstraction. Yeah. So that would be the real computer you have, and then you have the abstraction in the web store. So yeah, I mean the abstraction is also is the class in general. So we will have in this case maybe abstraction is not the best word, but we say the class. Yeah. So the object would be one individual computer, and then on the other hand we'll have the class. Yeah, we can also call this as the abstraction. The class would be the laptop, 30 inches, Apple MacBook Air, silver, and all this stuff. Actually, it can be named as the model of this computer. Yeah. So we have this computer. We have this class of the computers, but then we have individual computers. So that's the key point before we start with the object-oriented programming. This is the first point what you need to distinguish. Like if we talk about the computers or if we talk about the computers as the objects. So these are two different things. Yeah. So one more thing for each computers, what they can do, what they can actually have. First of all, they have the properties, like the type, the size, the information about the manufacturer, the color, the RAM capacity, disk space capacity, and so on. So it has the properties. So in this case, we actually define these are the characteristics how we actually define the properties of the computer. Yeah, so we have the properties, such properties. And in this case, the question to you, do the properties, I mean this list of property, does it belong to the, is it defined in the class or in the individual object? I mean, if we have the class, is it defined in the class of the computers or it is defined for each computer separately? If we have if we don't do any changes with this computer. Yeah. So That's the question to you. Do these things belong to the class of the computers in general? I mean, class of these computers, or to the separate computers? Like, of course, if we don't hack them, if we don't install some new software, but it is actually possible. It may actually be possible. So, I mean, the original properties. Yeah, that's correct. And the original properties come to the class. But in addition, yeah, this is what I just said. In addition, these properties may be changed actually for each computer separately. Yeah. So in this case, we already see the properties goes to the class. In this case, that's correct. But yeah, so that's the first step. First step, the values for the properties, they come to the class. But just one more thing to think about is that for each computer, so once you buy the computer, for some computers it is possible, for most computers it is possible, maybe there are some computers for which it is not possible to make any changes, but in general, so when you get the computer, you have the corresponding type, size, manufacturer, color, RAM capacity, and so on. So what we can actually take a look on here. So in theory, the type cannot really be changed, the size cannot really be changed, the manufacturer cannot really be changed, the color, of course, if you want to change the color of your computer, that in theory that is possible. So in this case, what we have? In this case, we'll have the default color, which comes from the class of the computers. I mean, these computers, yeah. And then we can actually, in theory, we can change it. So this is quite changeable value, which may be specific to the computer, but originally it comes from the class. Yeah, so that's some RAM capacity. In theory, it can be changed, but again, since we have the class with the RAM capacity 512 gigabytes SSD, then I guess 8 gigabytes RAM, then of course that can be changed, but quite specific. I mean, in theory, some properties original may come to the class and then changed specifically for each computer. But what I want to mention, there are some properties which actually belong to the class. So that is also the difference, the key difference for the object-oriented programming. Here when we talk about the classes and the objects, then we have some properties which belong separately to the object, and there are the properties which belong to the class in general. So this is also the good point to understand when we talk about the objects. Okay, see, are we starting something? Yeah, just any questions, let me know. Data accessors. I mean, these are the attributes, yeah, the attributes of the class. I mean, we'll talk about the classes, and these are the attributes of the classes. Yeah, actually, the data of the class. In this case, we can talk about the term data accessors. Actually, never used this term, but yeah, these are the attributes. Getting and setting the values. Getting setting values. These are the methods. Yeah, these are. We'll see that these are the. Actually, these are just the variables. From the programming point of view, these are the variables which store these elements. Getting and setting values. This, so that's also the next step for the classes. And objects, we also have the actions defined for the classes. Like for the classes in object, like for the computer, it can be turn on, turn off, like type something. Increase the brightness of the screen, decrease it, and so on. So we also have the actions. The actions which then can be done by the object, like again, type something, turn off, turn on, and then we may also have the actions which belong to the class in general. Like for example, that would be suggest the update. Yeah. So for example, that can be just maybe trigger the update of the computer. So once this method, this action is triggered, then this will be triggered for all these computers. So all these computers will receive the suggestion to update the newer version of the operating system. So in this case, that will be the action which belong to the class. Yeah. But again, some actions may belong to the object separately. Like for example, turn off, turn on, turn something. And yeah, about the properties, these are actually the from the point of view, these are the variables which belong to the class. Yeah. To the class or to the object. I mean, in this case, they will be defined as definition of the class. And here is actually, if we go a little bit ahead, then this is actually the difference between static and. You will see that this is the difference between the static and non-static. Yeah. So static, everything what is static, that belongs to the class in general. Everything what is not static, this belongs to the objects. Yeah. So we will talk about the syntax also. Now, so that's just to add new properties. You mean when the class is defined? Actually, not really. There are some modifications. Some modifications to the objects, but in general, I mean, when we have the class defined, the structure defined, additional property to the object. For dynamically, because the normal objects, that is not really possible. There are so-called expanded objects, but this case will not talk about expanded objects. So like in normal way, with the normal usual objects, there is no way we can add new parameters. So it means that we have the class of the computers defined, then we can only work with the properties defined there. But then we will also talk about the inheritance, about the subclasses, and for the subclasses you will see that it is actually possible to define the class which actually comes from which is actually inherited from this class. And in this case, we will see that we can have the subclass of these computers, and there we can actually add more elements. Yeah, so answering your question, in this case we use the concept of the subclasses. Yeah. The concept of the subclasses allow us to add new attributes to the. So it means actually have new class, which is a little bit not a little bit, but which is actually the inherited and the larger enhanced version of the original class. And this is what we will have. But for the objects, I mean, for the computer, you have all the slots defined. Like you cannot build the. So for this class of the computer, we do not assume that we have the option to let's say maybe change the size of the screen, for example, yeah, or create another screen. Like we can connect the screen, that would be correct, but we cannot simply create, let's say, another screen for this computer. Yeah, but yeah, maybe let's talk about it more deeper. So yeah. So in this case, the key thing is that we have something what belongs specifically to the class, some properties. I mean, not actually that we have the size and all these things, but the values which may come from the class, and also the properties which can be specifically assigned to the class, and then can be also specifically assigned to the objects. So let's take a closer look on the difference. Like here, let's say we have the class of the computers. Like in this case, we have more general class. And so in this case, it's actually the inheritance, because we have the class of the computer, so all the computers will have these parameters, but then we actually have the subclasses of this computer class. So it means that we have more specific computers, more specific details of them. And so it means that for each class of the computer we will have specific, in this case we can actually consider the story in two ways. So in one way we can consider that these are two separate classes, which both belong to the computer class. But on the other hand, we can take a look differently. So let's say right now that we have, like, the concepts may be different, so it's not confuse you now. So let's say right now that we have the class of the computers, like in general, class computers. So all the computers have these parameters. Yeah. So then we have this class of the computers. And in this case, let's say that we create the computer, which is the object, and the object would be then this computer, and then another object would be this computer. So in this case, the values of the properties, they will belong to the object separately. Like if we have the object named computer, so like not named, but the class is computer. So class is computer. Then in this case, the size, the manufacturer, and all these things, they may be different for different objects. And like in this case, these properties will actually belong to the object. Yeah. So in fact, again, right now it may be a little bit confusing, but I want to point out that there may be different scenarios. Yeah. Maybe first we will start with this. This is easiest scenario. When we don't talk about the subclasses at this point. So at this point, we simply we'll talk about the class of the computers. Yeah. So just the general class of the computers, without any specification of the model, of the manufacturer, and so on. Yeah. Just the class of the computers. So at this point, we may have two different objects. So we have just computer A, computer B. Two different objects, and for each object has the properties. Yeah, the properties may be defined when we create the computer, not we, but the manufacturer creates the computer, and then once the computer is created, then for each computer we have these properties. Yeah. So these properties and also the actions and the operations these computer may perform, they are actually different. Like say here we can play more games, here we can maybe study more or something like that. Yeah. So also the actions, maybe not the purposes, but the actions, the operations the computers can perform, they actually are a little bit different. And also the way how they perform them is also a little bit different. Like if we run them, let's say we have the common action for all the computers, let's say play the game. So if we play the game here, then on this object, then we may not get the best. Maybe we can play the game, but we will not get the best performance, because it has some characteristics which do not really allow us to play the games well. But then, on the other hand, we have another computer which has all the characteristics to enjoy the game, and then it means that we actually can, when we run the command, the action play the game here, then in fact we simply we have better game. In this case, we can say that we have better game. So again, the second point is that for both computers, the operations we define, they in fact may be the same, but how these operations are performed, they may be different. Yeah. So Yeah, and in fact, in this case, when we talk about the computers as the class, then in this case we have the properties of the computer. So these are the properties of the class. Yeah, I mean, it does not mean that they belong to the class. Yeah, so in this case, the meaning is a little bit different again what we say, which is static or non-static. Again, static belongs to the class, non-static is simply defined in the class. I mean, it should be defined in the class, but the values will not belong to the class. Yeah, so that's also a difference. In all the cases, the parameters are defined in the class, but not in all the cases the values for the parameters are defined in the class. And so that was also the difference between what we have here and what we had, what I talked about here. And so here, if we have the class as these corresponding computers, then the properties will belong to this actual class. But in this case, since we have the class computer, so it means that each object will have different properties. Then in this case, it means that these attributes, they are defined in the class, because they still need to be defined in the class. But in this case, they will be specific for each object. Yeah? So again, in this case, they won't be static. In that case, they would be static, yeah, because values are specified for the class. Yeah, like again, the properties is the values which are specific to the class, and which of course can be changed for one exact class. And these are the static. Where we have the properties which are different and are separately, the values are separately defined for each. We call them actually instance properties, but we can also call them non-static. And so it means that we have you'll see that we won't have static modifier for such. And yeah, so that was the introduction. I hope that was not quite complicated to you. Again, the key point is to think about, just maybe the summary about the introduction we have. First of all, we need to think about the difference between the class of the objects and the objects themselves. Like in this case, that would be computer or the exact computer. Yeah. So again, the class of the computer, it means that all the computers we have in the world. Yeah, so it means that this is the structure of the computer class, like what we can have for the computers. And then we have the computer as the object, which means that it's a unique created physical object. Yeah, so the class, in theory, the classes can also be physical, but that's maybe a little bit more complicated. Yeah, so object is physical, what we have, which is based on the class. So that's the first thing. Then the second thing is to think about the properties. So some properties may be specifically defined for the class, like let's say if we have the class of all the specific MacBook computers, then the values for this class will be specified, the properties for this class will be specified based on the class itself. But if we have the class of all computers, then the properties will be different for each object, and they will be specifically defined for each object. Yeah. So that's the thing. And yeah, so if you have any questions so far, please let me know. And now we can then actually start talking about the object-oriented programming in general. So what is it? That is actually the concept based on it is abstraction and object creation. I don't really like the word controlling more abstraction, because abstraction has, you'll see that abstraction has different meanings. So in this case, I would say based on the class and object creation for the classes and object creation for the system functionality. Yeah, and it is called object-oriented programming because in general way it is mainly orientated on the objects. Like in this case, we you'll see that the objects are the variables. No, sorry, they are the not the variables. They are the values. Yeah. So that's the key point. Also, to never mix the variables and the values, because these are two different things. The variables are the ones which store the values, but the values are actually the values. Yeah. So yeah, and the objects are actually the values. So again, when we will do the coding, when we will code the things, we should understand that we will actually use them, and that the values will be the objects. And actually already, just for your information, as I mentioned before, we already work with the strings, we already work with the arrays, and they are actually also the objects. Yeah. So, because again, the string itself, it's also, we have the class string, which means that this is the structure which defines the strings in general. Like for the string class, we know that. So what do we know about the strings? We know that the strings are so they have the structure. The structure is that they are the sequences of the characters. Like this is the array. The strings are the arrays of the characters. Yeah. So they have the length, they have the elements, and so on. So regarding the properties of the string, there are also some hash codes, but these are not quite specific. But yeah, the property would be the length of the string. So that is the property. So we have the class of the strings. Again, so in this case, just imagine the difference between the exact string, ABCD, and the class of all the strings what we may have. This is regarding what we already did before. And also the arrays. Yeah, for the arrays, we also have the class of arrays in general. Like we know the structure of the arrays. It means that this is the variable, the value, which actually stores other values. Yeah. So this is what we know. We know that the size is fixed, and so the arrays have the size, and so on. So that's also the part of object-oriented programming. And in general, this concept means exactly that we work with the objects. The example from you'll see it a little bit later, and also when you have the practical tasks, and also after this course. So just to understand the object-oriented programming from my experience, so actually the period, the point when I actually understand that what's in reality the object-oriented programming is, when I work with the web development. So the web development, because let's imagine just any website, or maybe not website, better web application, or just simply the application. So what do we know for application? Let's simply take the Microsoft PowerPoint. Here we have like this toolbar, then we have the screen, then we have these tabs, and so on. So they can actually store the values. Then we can have this list, let's say, and yeah. So just let's imagine how we can actually represent this. Actually, not only this, but yeah, let's say this application we have right now, the state of this application using the programming. like where and how to store all these things what we have here, because here we have, for example, the pointer at which slide we are currently I'm currently presenting. So there's this thing, then we actually have the list, the set of all the slides. What we have here, then we have the actual content of the slides. Then the question is, of course we can in theory read it every time. I mean, just switch to the next screen, read it from the file and so on. But let's say that all these things are actually, that we don't read them every time from the file, but they are actually stored in the programming code. Like, imagine that we run the program, let's say that's maybe C# or something like that, written in C# or in other programming language, and so let's imagine that this one needs to be structurized and also stored in some way. So, and in this case, this is basically the object-oriented programming. Like, we have the object as the list, so we have the list of 42 slides here, 42 elements. Then we have the, let's say, the array, which is also the object. Then this is the list itself, that's the object. We usually call them the collections. And then we have this screen, which is also the object, which has the specific values here. Yeah, so the values themselves are also the object. Then we have the pictures, the images, which are also the objects. Then we have these tabs, which do have some content under them, which are also the objects. So like that, let's imagine that each element from here is actually the object, which was its separate type. So every, I mean, yeah, currently I'm just saying that how we should basically imagine object-oriented programming and how we should basically understand. I mean, when you write something like this, when you write some kind of applications, then when you see every piece, every item, what we have, what we are working with here, so each item we usually consider, I mean, when you work with the, I mean, the area when you work on the application can be different, yeah, because it doesn't mean that you always will use object-oriented programming, but so just usually it will be object-oriented programming. Like, I'm not specifically know how the PowerPoint application is written, but most likely, yeah, object-oriented programming is used here. So I mean, in general, when you work with the, usually when you work with the web applications or just simple applications, then you may have some kind of different items here, and these items, they all are the objects. Like, just imagine about how to store all these things in the computer program. Yeah, so they should be stored somewhere, and yeah, so then I recommend you to imagine every point as the, I mean, let's say every slide, the list of the slides, and the content of the slide as the object, and this. So when you think, yeah, just think about it. Yeah, that's not like that's the definition, but if you imagine all these things as the objects, like again, what I see here, I see the and the PowerPoint in general would be the class. PowerPoint file, yeah, that's fine. But in this case, that will be a little bit trickier. Because I mean, let's say here we have multiple classes. Like here we have the slide, which is actually the class. Yeah, like we have the slide. It has the properties. Say the property would be the content in general. So we have multiple classes. Yeah, actually here we have, you'll see, we have the composition of the classes. In general, that would be, yes, when I agree with you, that would be some kind of the class of PowerPoint file. Yeah, or maybe even more trickier. But in general, you will also see that we have the yeah, I mentioned the objects, like we have the composition of the objects. We have small pieces of objects, like the picture itself, that's the object, which has the size, which has the position on the screen, which has the, say, some technical parameters, how it looks like. Then we have another picture, which is, actually, so yeah, here let's say we have two objects from the class picture. And so this is the object of the class picture, and this is also the object of the class picture. So this one has the parameters values. I mean, the parameters are the same. Let's say the size, the colors. They use the resolution, all these things. Also the, say, the captions, and yeah. So these are two objects. And what I basically mean that we can, like, the text here, that's the object, and the title of the slide, that's the object. And in general, we have the slide, which is the object. Is the object itself. Yeah. So, and what I want to actually point about that here we have multiple objects, and we have also each object belongs to the class. Yeah. It means that this is the class of the. Again, this is the class of this object belongs to the class of the images. This one as well. And they are two different objects, but they belong to the same class. Then we have the class of the, say, that's the main content. So that's the class. It has the parameters, which are the content of this object. Yeah. So in this case, we actually have the combination of the objects. Again, that will be a little bit difficult at the beginning to understand, but just yeah, from my point of view, that in future, again, maybe not at the beginning, but in future, if you think about the construction of the application as the construction where you have different objects, and each object has a state. Like at this point, I'm changing the state of the object. I'm not changing the state of the class, but I'm simply changing the state of the object. Like here, I changed the size. So now the size of the object will be different. The width and the height will also be different. So if I change it, yeah. So again, the class itself is not changed. The class of the pictures, that will remain the same. But the object, this object specifically, is changed. Yeah. So, and all these things. So, I mean, each object here, they may have the state. Like I delete the slide from here, I delete the element from the list. So I changed the state of this object. Yeah, the object is the list. Then I modify something here. I change the state of this object. Yeah. Again, maybe a little bit hard for now to understand. That's just my recommendation, but I hope that at some point, not I hope, but I definitely know that at some point you'll understand what I'm currently talking about. Yeah, because yeah, that's basically the, yeah, when I say not also, yeah, it helps to understand how the object-oriented programming works, but in addition, you will really understand why it is actually named object-oriented programming, because everything is based on the objects. Like here we have the object, here we have the object, here we have the object. It's the file itself, that's the object, and all these things. So like, and yeah, so usually for building different applications, you will see that that it is actually based on different objects. Yeah, it's combined from different objects. This is what I want to say, and this is basically why the name is named object-oriented, why the topic is named object-oriented programming, because yeah, in general it means that the building of the program, building of the solution, is based on different objects. Yeah. So again, we'll talk about what are the classes, what are the objects a little bit later, but for now, yeah, so that's just the understanding of the definition of the concept, and that everything is based on different objects. So okay, so I can give you now 10 minutes to to think about what we already talked about, and then we can meet after the break. Okay, so let's continue. So again, the object-oriented programming in general, the concept which is where when we actually based our programming, based our coding on the objects. Yeah, I mean, here we see the objects as something what is moving, something what is staying, at some point it is popping and popping up and so on. Yeah, but again, this can actually be represented in another way using the programming, using the coding. And this is what is actually what we'll talk about, how to represent them with the coding. So two things what we have for the objects. The objects may have the characteristics about themselves, so this is what the attributes. This is what we call the properties. And one thing I also mentioned sometimes, these are the behaviors. Like for the strings, we already know that we can do some. We have some behavior for the strings, like we have the method equals, for example, which returns the result if the word equals to what we provide here. Then we also have the behavior which is contains, which actually provides us the output if the string contains the value we provide to this method. So this is actually what the functions are about. So behavior is defined by the functions, by the methods of the objects. Again, the previous example we had strings. For the strings we have the properties, the length, the actual values, the actual array of the characters, and then the behavior. These are basically the methods what we can call directly from the string. Contains, equals, what else we have? We can clone the string, we can copy the string, in this case this is what comes from the arrays. We can get the type, insert the value to the string, and so on. So these are called the behaviors. This is basically what represents the behavior of the object. In general, it means that it may apply some changes, like in theory that can be from the string point of view that it is for the string we cannot actually do it, but for some objects which we can actually modify. So let's say that would be computer. So this will say that please restart. So it means that it will change some of its characteristics, like not these characteristics, not these properties, but let's say the state. Let's say the state can be power on, power off. Then also can be some, let's say, memory available. So how many memory is occupied, how many available. So in this case, if we delete the files, so let's say we have the operation delete, delete to one exact file, then it will delete the file from the storage. So this is what it is about. So behavior and the properties, and this is what belongs to the object and the classes. What we will cover in this topic. So, and here's the example. When we consider when we talk about the properties and the objects, or the properties and the behaviors. So, let's say we talk about the computer. That will be the object. So for each computer we have the size, the weight, the color, area, capacity, screen size, price. So what the computer can actually do. So we can ask computer to start, then it will power on the computer. Creating Excel table, so that would be the method. and also playing games. That will also be the method what we can actually do from this computer. Like yeah, in this case, maybe playing games, but actually playing games will also be the relevant example. For the car, then we can also have size, color, door amount, engine type, and so on. And then from the behavior point of view, we may again have starting, braking, acceleration, and similar thing. So just basically what we can do, but what basically the objects can do. What we can call from, what we can ask object to do. Yeah, also it may have some output, like in this case these would be simply voids, but they can also be the output of these behaviors, and mostly, let's say not maybe mostly, but in most cases we'll have the situations where there will be the output of the behaviors. I mean, again, just let's be honest, the behavior means the function, the method. The functions, the methods. What we have under the objects. Yeah. And as you already know how the functions work, how the methods work, so this is what basically the behavior of the method is about. Yeah. Or behavior of the method. Behavior of the objects is about. Yeah. So, and for the functions, for the methods, as you know, we have the returning type. When we have the returning type, we have the parameters, what we can provide to this method, and what can also be returned from this method. Yeah, so then let's say we have the object student, which has some typical parameters like again, name, surname, and so on. Then for the student, we can, let's say, calculate the average grade, do the registration for the subject. Like in this case, that would be the method where we provide the subject name, and then this method will do the registration. In what way that would be? Let's say that it will maybe do the change in the database in normal way, or just update some local objects and local in the code. So many different things can be done there. Yeah, so that is about the concepts in general. Do you have any questions so far about the concepts? Like at this point, yeah, just the short summary. What we have in this topic. So first of all, first thing to distinguish the classes and the objects. So that's the first thing to understand in object-oriented programming topic. Okay? So just understand the difference between the classes and the objects. So I mean, we not talk about programming now. I mean, just not programming. I mean the coding, but the concept is general. What's the difference? That's the first thing. Second thing is we have the properties and we have the behavior. We have the methods. Yeah. So we have the attributes. I mean, the properties, the synonyms would be the attributes, the characteristics. I will maybe use one of these three words. Just please know that this will be the same. Behavior, and when I talk about the behavior, it means that I talk about the functions, the methods, what belong to the object, or they can also belong to the class. Like let's say that for the let's say we have the class of so in general that would be the class of car, specialist in cars. Again, maybe about like student. Let's imagine we have the class of the coffee, for example. Then no, the coffee won't be the best example, I guess. I mean, no, the copy itself it can be, but maybe at this point it will be complicated to imagine some examples. So let me think about say mobile phone, so smartphone. So that will be, so for the smartphone, you know that so we have the properties, and the properties would be that we have the size, again the screen size, the processor used there, and so on, so all these things. So that would be, these would be the properties, and each property will be specific for each object separate. Like we have the class of smartphones, and then we have the exact smartphone, what you have in your hand, for example, that would be the actual object. Then we have the properties. The properties, again, each smartphone has its own properties. In this case, and these will be, we'll talk about the properties and behaviors for both these properties and behaviors. There are two options. They can be static and non-static. This is what I said before. And the difference here is that the static is something which belongs to the class in general, and non-static it is what belongs to the separately to the object. So I guess for the objects that pretty much straightforward. Yes, that we have the exact size, weight, color, and so on. But what about the static properties and static methods, behaviors? So again, when I talk about the behavior, maybe I will mostly use the term methods, because this is what we usually use, technically what we usually use. So then what about the static properties? Static properties may be something what is general for all the class. It means that this is something what belongs to specifically to the class, not to the object. Like usually it will be something that if we change it, then it changes for all the. It means that it is something what actually changes for all the class of this object. Like let's say we have the class, the class, say iPhone, not sure, say iPhone 10 or iPhone 12, not sure which model, let's say iPhone 10. So that's the class iPhone 10. So then what can be the static property in this case? Again, the non-static properties, non-static attributes, these are all these like the the static property would be that specifically what belongs to the block class of iPhones 10, and this would be, say, the size, the screen, the memory capacity, and so on. But so these are all the static. In this case, these will actually be the constants, but this will be maybe the next topic. So this is something what cannot be changed. But also there's something what can be changed time by time. Like we cannot change the size of like if we have the class of iPhone 10, so the class is already defined, the objects are created. I mean the smartphones, iPhones 10 are created, and so such properties like size, screen, they are not changed. So these are fine. So in this case, these will actually be the constants, but that's more specific topic. We'll talk a little bit later. If we talk about the simple properties which are not constants, so let's say, for example, it can be the latest version, the latest operating system version, what is available for this particular class. Let's say the latest version what is available for iPhone 10. And this is what will change time by time. So, and this will actually be the static property, static attribute of this iPhone 10 class. It means that if this one is changed, then for all the objects, yeah, like for all the iPhones 10 in the world, this will be actually the last latest available version. Yeah. So that in this case this will be static. Yeah, static, because this will basically what will belong to the whole class of objects. Yeah. Like yeah, the latest version as the example. What else? If you know, you can simply type the examples. What can be the property which will then belong to the whole class, and then we can, if it is changed, then it will be changed for all the objects in this class. Yeah. So for example, the latest version of the operating system will be the static attribute of the iPhone 10 class. Yeah, so that will be the static property. Then what about the static methods? Static methods, for example, let's say that the most primitive example I can imagine, that would be to get the information about the iPhone 10 class. Like, let's say we have the method which say prints the information about the iPhone 10 class, like all the properties, all the technical things, the latest version, and everything like this. So that would be the static method. Yeah. So basically, static method is something that is not specific to each object. Like, we cannot say that the static method is turn on. Yeah, because we cannot simply turn on all the iPhones. Yeah, in fact, and we cannot also turn off, because that is also possible to turn off all the iPhones. Maybe in theory that's possible. I'm not sure how the Apple structure works there, but yeah. So this is not what is normally possible. Yeah, it is not also possible to maybe change the brightness for. Actually, maybe it is possible to change the brightness, but so this is something what is specific for each, say each iPhone 10 smartphone separately as the object. Yeah. So what else can be static behavior? So static behavior would be, let's say that force update. Yeah? For example, all the iPhones should mandatorily be updated to the newest version. Yeah, so for example, in this case that would be some static method. Yeah, which again, not something that something that will be triggered for each object separately, but with the class in general. Yeah. So. Yeah, and lots of different things. In fact, you'll see that the classes are more flexible. Like previously, we had the regex class, and here we have the static methods, which actually allow us to provide the values there and to get the result. So in this case, no object is needed to perform these operations. But as another option would be that we create the object of regex, and then the operations may be performed in the object way. We'll maybe wait a little bit later to do it, but in general, you'll see that lots of classes allow flexibility here, so they can be used. So they're the static and the behavior, the methods can be used as the static, and they can also be used as the instance. Yeah. So again, if we talk about non-static, then we use the term instance method. Yeah, instance attributes, instance methods. So in that case, we actually have such flexibility. Yeah, so for example, we will say we will have the iPhone 10 class, and this could be there can be the method which produces the iPhones for, like, let's say create new iPhone. So that will be the method which will actually return us the new iPhone back in return as the object. Yeah, also maybe to replace some components, so that can also be the method. Yeah, which will allow to replace the components, and so lots of different things. Yeah, so we'll see more examples, but actually we already work with some different static methods and also some different non-static methods. Mostly again from the strings and from the arrays, but also yeah. So for the strings, also we use the static methods. Like for regex class, this is static method replace. So we don't have any object. We simply have the class regex, and then we have the method replace. Yeah, so nothing needs to be created. No new object needs to be created to call this method. Yeah, that's the actual thing. To use the instance methods, we need to have the object. Without the object, it is not possible to call these methods, and also to use the attributes. It is not allowed. Okay, so do you have any questions so far? Okay, then if not, we can move on. So okay, then maybe we can take a quick look on this slide, and then yeah. So basically, why object-oriented programming? The main thing what I wanted to share today with you was this example about let's say about the application. Specifically, I talk about what you can see here, the PowerPoint, but just any website, any web application you take, it has some components, yeah, and each component is quite specific, so it's not linear. Yeah, like it is not simply text here, text here, text here. No, it has may have the pictures, the state, the positions of where it is located. Like here we have the position in the list where this slide is. That's the 9th slide. It can also be the 4th and so on. So that's that is where it is located. So what else can? Yeah, basically we can imagine everything as the object, and in general we can also have the composition of the objects, and object-oriented programming is actually needed to then be able to manage all these things. Yeah, we'll see that using OOP approach we can manage, we can change them, we can act with them. So like in this case, we can move the object, for example, we can change the size as shown before. Yeah, so this should be also written in program in some way. Yeah, it cannot simply be like we say, I would like to see it like this and that's it. No, there is also the program behind this, and it should be constructed in some way. And like the easiest way, as I said, would be that you simply understand all the components as the objects, and then after that we can use them. So again, in general, that's the motivation. We want to deal with different complicated structures. Yeah. So these structures can actually be represented as the objects. So as the result, when we have this definition of all these things, then what we achieve that that our program, our structure program, is faster and easier to be executed. Yeah, again, we at this point we think about the application or something similar as the set as the combination of the object. And that is how we actually write them in code and store them in code. Yeah. So that makes it faster and easier to execute. Then the structure is more clear, because otherwise that would be quite complicated to write the structure in the procedural way. It is actually possible, but yeah, we'll see that exactly the structure of the code will be the key point here. Yeah, also helps to keep the code right, not repeat yourself. Like again, when we talk about the code, then you'll see that using the object-oriented programming we can reuse so many different pieces of code. Then it makes it also possible to create full reusable applications for less code. Yeah, that's also from the previous point. Yeah, so the code will be shorter. You'll see that the code will be shorter. The code will be clearer, and in fact, it will actually do more complicated things than the code without using object-oriented programming. You will see this. And yeah, so don't repeat yourself. And so it means that actually not repeat the code. That's the usual problem, that lots of people just simply write the code without thinking about the reusability of the code, how this code can be reused in future, how this code can be structured, and how this code can be read by others. So that may be quite a complicated thing. And object-oriented programming, you will see that it will help. It will definitely help us to achieve all these things. Yeah. So then that's about the reusability. Okay. Do you have any questions so far? Yeah. Tomorrow we will have to recap about the concept. So in case you missed something, then tomorrow we'll definitely have the small recap about the object-oriented programming concepts, and then we will move deeper to the actual coding there. Okay. So do you have any questions for today? Okay, then if not, then thank you very much for your attention today. Just in case you have any questions, also maybe for tomorrow, you can prepare and then we can discuss then tomorrow. And then, see you all tomorrow. Have a nice evening. Bye.